Welcome to Carlton's Math Corner. Today we are going to discuss the distance formula. At this time, please make sure you have your math journal, vocab packet, as well as something to write with. Today our target is I can use the distance formula to find the distance between 2 points on a coordinate plane. Okay, so here we have a coordinate plane and 2 points have been plotted. And I want you to figure out how can you find the distance between these points? Well, here's what I notice. I notice that if I start at ordered pair 1, 2, and I move right 2 and up 2, I actually get to ordered pair 3, 4. Okay. The other thing I notice is that if I take another line and I connect them, they actually create a hypotenuse of a right triangle. These are the legs and this is the hypotenuse. In our previous videos, we actually use the Pythagorean theorem to find the hypotenuse. And so we could do the same thing. So we could go 2 squared, which is 4, plus 2 squared again, which is 4, equals c squared. And now I know 4 plus 4 is 8. And now I just need to find what c is. And in order to do that, I need to square root it. And so if I'm going to square root it, and I got to make sure I square root the c as well, but if I take the square root of 8, if I put that in the calculator, I know that I'm going to get 2.82427, etc. And so I'm just going to round this to the nearest hundredth. So that means that the 8 to the right in the thousands place is actually going to bump up my 2 to 3. So 2.83, and I'm going to write that down. Okay, so 2.83 would equal c, and that would be my distance between this point and that point. So we actually, what do we use to find the distance? Well, we use the Pythagorean theorem. So that is one way that we can do this. But we also have, there's another way to do this, a quicker way. Instead of having to plot our points, figure out if it's a missing leg or a hypotenuse, and then use the Pythagorean theorem. And let me capitalize this. If there's another way, okay, so I want you to look at this. How is this similar to the Pythagorean theorem? Okay, first of all, here's what I notice. I notice that there is one thing squared plus another thing squared, and then it equals a third thing. Okay, isn't that similar to a Pythagorean theorem? Isn't Pythagorean theorem a squared plus b squared equals c squared? Well, this is similar to that in the fact that a squared they found by taking the x's and subtracting them. Well, if I subtract the x's, that's on the x-axis. If I take the 3 minus the 1, isn't 3 minus 1, 2? And if we go back to our work, didn't we have a distance of 2 on the x-axis? and our distance on the y-axis was 2 as well. Let's see, is that what we get if we subtract here? Yeah, 4 minus 2. If we subtract the y's, we get 2. So it's actually the same thing that we just did, but it's a formula that we're using. It's a different formula. Now, I know c squared, I know this says d squared, but it is very, it's still the same. We're still taking a number and squaring it. Okay, why do they have a square root over the entire problem? Like, why is it shown here not over one number, but it's over the a squared plus the b squared? Is it similar to the Pythagorean theorem? I actually noticed that it is similar because, okay, when you use the order of operations, okay, usually we have to do the parentheses first. So we would get 3 minus 2 is 2, or 3 minus 1 is 2, 4 minus 2 is 2, and then after parentheses is exponents, so 2 squared is 4, 2 squared is 4, and then we would have to add them together, which is 8, and then we take the square root from that, correct? Well, isn't that what we did with the Pythagorean theorem? Didn't we square the 2, then square the other 2, and we got 4 plus 4, and then we added together, we got 8, and then we took the square root, and we got 2.83. Now, I know this one says 2.8, but that's just because it was rounded to the tenths place. I'm going to put down the 3 just so there's no confusion. But it's the same exact steps. The reason why I'm showing you this way is because this is actually what we call the distance formula. So here's the distance formula. It basically states that if we subtract the x coordinates and we subtract the y coordinates and then square them and find the sum between them, if we take the square root of that sum, we will get our hypotenuse or our distance. And it's just like what we were doing with the Pythagorean theorem. Very similar steps. The only difference is we're working with coordinates. And so what that means is we have to figure out the distance between our x's and our y's in order to figure out what the legs are of that triangle. Okay, so this formula comes in really handy so that we don't have to actually make a graph. We can actually just use the x's and the y's that we're given and just plug them in and then figure out, the answer for that distance. And so here is a couple examples. So here are 2 pairs of coordinates. So we have 6 and -9. And 9 and -9. And if you look at the distance formula, we have the first step was to plug in these coordinates. Well, first of all, we have to look at the x's. So here are the x coordinates. And we are putting in the second one first. So second one always goes in first. So we have 9 minus 6. And then over here we have -9 minus -9. And those are our y coordinates. So here's y. Okay. So they're plugged in right here. And our x's are right here. And then once we subtract them and find the difference, 9 minus 6 is 3. -9 minus a -9 is actually 0 because we're subtracting both. And then we could square those. We get 9 and 0. 9 plus 0 is 9. And then take the square root of that. Square root of 9 is 3. And so the distance between those 2 points on a coordinate plane would be 3. If you look at this last problem, so first of all, we took the second x minus the first x, and that's right here. We got -7. and then negative 3 minus 2, oops, I'm sorry, negative 1 minus 2, negative 1 minus 2 are the y coordinates. And then we square that. And so once we square these, we get 49 and then 9. We add them together, we get 58, and then take the square root. And we're always going to take the positive because we're dealing with distance. Okay, so to the nearest tenth, it would be 7.6. What I would like for you to do is I want you to figure out, first of all, what are these ordered pairs? And then I want you to find the distance using the distance formula. Okay? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.